Hey everybody, Mrs. Herman here. Thanks for joining me. Now that you have played the tug of war game, we're going to go ahead and dive a little bit deeper into the strategy behind it and answer problems 380 A, B, and C. So I went ahead and you're welcome to pause this real quick and do the same. I just copy and pasted this from the directions above because I, like you guys know, I'm a visual person. I need to see that game board in front of me to help me kind of make sense of what's going on. So we are going to go ahead and talk about 380. So it says Cynthia, Devin, Gavin, and Mark are all playing the tug of war game. Cynthia begins her turn with her marker at 15. So I'm going to go ahead. I'm going to mark her at 15. She spins a 1 and a -3. She thinks that she might be able to get to the winner space 11 with this spin. Is she correct? Explain why or why not. So she would need to go 1, 2, 3, 4 spaces left. So she would need to go left 4, or in other words, -4. So is there any way to get a combination of 1 and a -3 to get to -4? So if you need to, you can go ahead and just list all of those different combinations. I can add them, I could subtract them, I could multiply them, or I could divide them. And if I do that, 1 plus a -3 would get me to -2. So that would go -2 spaces, and that's not what I want. So that one's a no-go. I could have a 1 and take away 3 more. So take away a -3. So remember, that's like saying 1 plus 3 is going to get me to +4. Now I want a 4, but that would get me off the game board. I would be going 4 to the right, so I'd be at 19. I'd be off the game board and lose my turn. I want to go left 4. So this is not it. For the next one, if I do 1 times -3, I could go to -3, and if I go here, 1 divided by -3 is going to give me -1/3. So you might think, well, she can't win. Nope. Well, don't forget, let's switch the order. Okay, and let's see what happens. If I switch the order and let's say I say -3 plus 1, is that going to change my answer from the one right next to it? No, that's going to stay the same. Remember, when we are adding or multiplying, okay, based on that property we all know about, you can switch the order and it's not going to change. That's called the commutative property. So this one's not going to work. I also just said that -3 times a 1 is still going to give me that -3. So that's not going to work. But when I talk about subtraction and division, order matters. The commutative property, does not apply to subtraction and division, because when you change the order, you're changing your answer. So let's switch the order here and say I'm doing a -3 minus 1. If I've lost $3 and I lose 1 more, I've lost a total of $4, and that looks like it's going to get me to that -4. If I double check really quick, -3 divided by 1, anything divided by 1 is itself. So that gives me the inverse of my answer from over here, which still won't work, but this one will. So if she, when it says explain why or why not, make sure to explain in the section when you submit this, that when she subtracts -3 minus 1, she's going to get -4. So yes, it is possible because of that. Okay, she can definitely win. All right, let's move on to Devin takes his turn. So let's change Devin to a different color marker. Let's go to blue. His marker is on the 1, +1, and he spins a 4 and a -3. Is it possible for Devin to get one of the winner spaces at 11 or -11? Okay, with these numbers, and explain your answer. What do you guys think? Do you think that he is able to win or not? Okay, so this one's tricky. You might initially think, no, he can't, but yes, he actually can. He cannot win going this way, but he can win going the other way, because he's trying to go 11 spaces to the left, and he's got 1 extra space there. So he needs to move a combination of 12 spaces negative. Well, I already see a 4 and a -3. And if I know my math facts, I know 4 times 3 is 12, and because one of those is a negative integer, I can then get a -12. So because 4 times -3 will give me negative 12, or you could obviously also say this the other way, since it follows the commutative property. Either way, whoops, negative 12 would get me there. Okay, so yes, he can win. Make sure to take some time. I'm not going to explain for you. You guys explain your answer, how that works. Why does 4 times a negative 3 get me to that negative 11? Okay, awesome job. And let's go on to letter C. Oops, sorry. Letter C, Gavin now has his marker at 12. So, Gavin's at 12. Okay, and he spins a negative 3 and a negative 2. Okay, Gavin is wondering if he can win on this turn. Okay, can he? So he's got a negative 3 and a negative 2. What do you guys think? Think of all the different combinations. Is it possible for him to win? Okay, if we list those different combinations, negative 3 plus a negative 2 is going to give me negative 5. Well, negative 5 is not going to make me a winner. And I know that's the same thing for if I switch the order, so I can't just switch it and get a different answer. It'll still give me negative 5 for addition. Let's go ahead and do negative 4 minus a negative 2. If I do that, that's the same thing as negative 3 plus 2, and that's going to get me a negative 1. Okay, that one's not going to work. Oh wait, for this one, sorry, it's going the wrong direction. This one would work. If I want to go left 1, it's going to whoop, hop right over there, and I'm going to move to the left 1 space. So when I do negative 3, oops, wrong thing, highlighter, there we go. When I do negative 3, take away a negative 2, that's going to move me 1 space to the left, and I'm going to win on 11, or Gavin's going to win, sorry. So make sure to explain why Gavin can win in this section here, and then go ahead and submit this item to the assignment in Schoology, and you guys are set. Awesome.